Here's our review of quiz 6. In problem 1, we're given pairs of variables and asked to tell whether we would expect a positive association or a negative association. So for the first one, number of years of education and annual salary. Well, doesn't it make sense that the more education you have, the higher your salary will tend to be? So that would be a positive association. Next, we have age of an adult and maximum running speed. And unfortunately, as an adult ages, the adult tends to slow down. So as the age increases, the maximum running speed will decrease. And that would be a negative association. But for part C, it's age of a child and the maximum running speed. Well, for children, as they age, they tend to get faster. So as age increases of a child, maximum running speed increases. That would be a positive relationship. And D, the age of a man and the age of his wife. So older men tend to have older wives. Younger men tend to have younger wives. So as the age of the husband increases, the age of the wife tends to increase as well. So that would be a positive relationship. Now here in problem 2, we're given a pair of scatter plots, and we're given some choices about what the sample correlation could be. Now, on the one on the left, we see a downward trend, a downward linear trend on that graph. So right there, we can just restrict ourselves to negative correlations. And this is a fairly strong correlation. The points do not lie exactly on a line, but they are pretty close to an imaginary downward sloping line. So that's a strong downward correlation. We would choose negative 0.9 as the best choice. On the right, we see an upward trend, but this one is not as strong. This would only have moderate strength because the dots are a little more scattered about an imaginary upward sloping line. But still, it is a positive trend. So we would choose positive 0.5 for R. For problem 3, part A, we were asked to circle the dot that has the largest residual. And that one's pretty easy. The one I circled is the one that's farthest above the line. For part B, putting a square around the dot that has the largest negative residual could be a little bit tricky because you might at first glance think it's the one between 30 and 40. But what we're looking at is not just how low it is, but how far it is below the line. So that one between 50 and 60 is farther below the line than the one between 30 and 40. So that's why we put the square around that one. In part C, it asks us to predict the body mass of a mouse that eats 50% of its calories during the day. So we just simply use that formula that was provided and substitute 50, and we get a prediction of 7.46 grams. Now, next, it's about a mouse that eats 48.3% of its calories during the day and weighs 5.82 grams. So let's note first that the observed body mass of that mouse is 5.82 grams. We could also predict that a mouse that would eat 48.3% of its grams during the day would weigh 7.24 grams by using the regression equation. So the residual is always the observed value minus the predicted value. It doesn't matter, as in this case, if the observed value is less than the predicted value. It's always observed minus predicted. So 5.82 minus 7.24 is negative 1.42 grams, meaning what we observed is less than what we would have predicted by 1.42 grams. Now in part E, it asks us to interpret the slope. The slope of that regression equation would have been the 0.127. So we would say the mouse's predicted body mass increases by 0.127 grams for each additional percent of calories consumed during the day. In general, that's how we do it. We make reference to the value of the slope, and that's how much the y value increases by for each additional unit of the x value. So in this case, the x value was the additional percent of calories consumed during the day. And then in part F, to interpret the intercept, well, that would mean that the percent of calories eaten during the day is 0. So we could say a mouse that consumes no calories during the day is predicted to weigh 1.11 grams. Is that meaningful or not? Well, since this is rather light even for a mouse, the intercept might be considered meaningless. But this one's a gray area, so I wouldn't expect you to declare that it's meaningless or not. On the other hand, if we had a regression equation where the intercept was negative, then definitely that would be meaningless because a mouse can't have a negative body mass.